Recording. Okay. Okay.
For Madison and West Norwood, it's also
I mean, there's multiple weekends.
Okay.
Okay, can you explain why you did this? Because like it does
Okay.
somewhere, but
So
what is X plus delta X? Why is it-
up there is your change in Y. Okay. So I said I was going to plug this in for X in my function. And then I'm subtracting the function just as is.
Right.
So when I did this, I plugged that X plus delta X in here. Since I had a variable right here, I plugged it in there. So this is kind of that beginning part. And then over here, I just subtracted the function as is. And then it's all over delta X. Like if this 2 didn't have anything there, it would have been that plus 2 and then minus the whole thing. Okay, that's all I did there. So you plug in that anywhere you have a variable. And like on, you know, for something like this, if this had like an x cubed plus 2x, like plus 7. Okay, then behind this, I put a plus 7 and then minus, and then I just subtract out that whole thing.
So the X plus delta X is the same thing as X for the original.
Yeah, that's what you're dumping in. Okay. All right.
I know you said that, sorry.
No, you're good. No, ask questions because this is something completely different and something new. And I tell you what, I didn't understand why I did this in Calc 1.
Until you got to Calc 3.
Calc
all
3.
just went together.
I was like, that's why I did it. Oh yeah, it was mind-blowing that day, I'm telling you. Okay, so
I gotta make up for the lack of people.
No, you don't. You really don't.
there's one person missing and she's not loud.
Well, no, I'm talking about like the 30 kids that.
Okay, so for this right here, okay, so we need to multiply this out.
No.
Okay, so let me kind of do this with you. I'm not going to write all of this stuff going down. Just, I'm going to work over here. Okay, so this is why I kind of gave you some room. I'm just going to start with just this part. Okay, you're foiling. That's all you're doing. So from this plus sign on, I'm not doing anything with it. I'm just focused right here. Are we good there?
Yeah.
Okay.
Imagine if we had those like normal tiny boxes.
Huh?
Like I'm just saying, if we have those normal, usual tiny boxes.
Okay, so if I multiply these first two. Are we good if I foiled those first two? Are you good? Yes? Okay. Now, for the next one, you can just like take X times all three of those things and then delta X times all three of those things. And then we'll just kind of clean that up a little bit. Where did I stop? 1, 2, 3. Okay. Okay, so all I did, stupid thing better be recording. Okay, it is. Okay, so all I did was foil the first two. And then I just took x times all three of those things, and then delta x times all three of those things. That's your mad algebra skills right there.
Oh.
Okay, let's clean this up a little bit. So I have x cubed. I have a 2x squared and a 1x squared. So how many do I have there? I have 3. I have an x and a 2x. These are like terms, remember? Because they have the same.
X squared is also delta x.
Yeah. Oh, sorry. Yeah, I covered that up. So now I'm just adding these two things right here.
3x delta.
Okay, so if you clean that up, all of that, that's just that cubey part right there. Okay, so that's just cubing. Are we good? And we added things that were alike.
We add them one more time.
Huh? Okay, so the x cubed, I didn't have any other x cubed, so that's here. I had a 2x squared delta and a 1x squared delta. So I had 3x squared. And then I had 1 delta x squared and I had 2x delta x squared. So there's my 3 and then there's that.
That's disgusting.
Okay, now I'm gonna tag on the rest of this. So now I'm kind of going back there.
And then the x cubed cancels out.
Okay, so this chunk that we simplified right here was just that beginning cube. And then when you took this times 2, and then remember distribute that minus sign on both of those.
Oh, and then the delta x.
Oh,
cancels
wait.
out. Oh, wait, no, it won't.
Yes.
No, it's. Okay, so are we good right here? Because remember, just this part was just us multiplying some stuff. Chances are in a test, I probably wouldn't give you something that hard, and maybe something like a square, maybe to do, but okay. All right, now, Sam, you said x cubed. Plus 2x minus 2x. Okay. Now, all I have left is,
What is that? Plus 2x.
That was from the 2 times.
right here.
Oh, I forgot about that.
Okay, now look at the remaining stuff up top. What do they all have in common?
Delta x.
All right, so let's factor that out.
Well, now you can cancel out the 2. The delta x on the top.
Okay, now I'm gonna rewrite just this part of it because I left it at the top. Okay, you still recording? Sorry, Victoria. Okay, Adam, you said that cancels that, right?
Yeah.
Okay, and as delta x goes to 0,
Whoa, it's just 3x squared plus 2. Oh my god, guys. That's stupid. So what is it?
I can't wait till you go off to like Iowa State and get to your engineering. Oh, that's stupid.
They're just here in the back corner of the room.
Adam's laying on a row of desks up at Iowa State. Well, that's stupid. Okay, so for this one, we're talking about the slope of the line at a certain. This is it. So now, if you plugged in
So what does this mean?
a value for it, that's the slope of the curve. So now, if you plug in any like point on that curve, it'll tell you the slope at that tangent point.
You show that.
Explain that further.
Like, can you?
Well,
Walk on to Desmos real quick.
well, this is a cubed.
Yeah.
So it's just any point on that graph. Here, yeah, we'll do Desmos. We can.
Desmos.
Or could I just do it on here? Here. Let's do it on here. Let's do it on here.
I think how Desmos is not look like, but Jimmy John's voice.
Listen here.
She's got her priorities.
Jimmy John's was live every Friday. Oh, hey.
Until they ban whatever.
Okay, are you still there? Yeah. Oh.
Navatro's.
There was a countdown. Caught it. We need to time that when that pops up. Okay, where's mine?
It could be 10 minutes.
Is it?
I think so. I think that's what Oscar was talking about last week. If they let you know, then it'd be better.
Or like if you could set it, be like, give me a reminder every 20 minutes.
So you're not just recording on accident, you're recording for 3 hours.
Okay. Well, this is an outstanding.
Desmos.
Oh, okay. We're gonna have to do that now. Okay. So now it's if I draw any tangent line on this graph right here, that'll be the slope there. So if I plug in like, 2. Now 2 would make this a pretty steep line if I plugged in, because 2 is right here. So my tangent line, it's not vertical, but it's really steep. If I drew a tangent line, so if 2's right here, and I go up here, and I drew a line in here, a tangent line at 2, that would be the slope. So if I plug 2 in there, 2 squared is 4, 4 times, so my slope would be 14. Because it's so steep right there.
So it's not like a parabola. It says the slope.
So that creates the slope. For
Because you don't have a slope with a curve.
So this.
You know, you're used to linear stuff. I said when you get to calculus, it's curvature.
So this creates a linear line. A line.
Well, sometimes it'll look like a linear line. Sometimes it
So
won't.
like that's like the original, right?
Yeah.
And then so we select like 2 at like 2x, right?
Okay.
So then that would be like, so then we calculate that, that's like 14 or whatever.
So if you drew a
So
tangent
it'd be
line
it'd be
at
like
2 through there, it should be a pretty steep line at
But-
2.
But it's not a parabola that goes through.
No,
That doesn't
this right here, this could be lots of different, you can get lots of different answers for something like this. It's when you plug your tangent point in there. That's what tells you what the slope is. So once you math, okay, my slope is 14. Because if you look at, not so much Adam's because his wasn't as steep, but if you look at mine, at 2, if you're trying to draw a tangent line at 2, it's not a vertical line, but it has to be pretty steep. It's not just the point of 2 whatever. No, it's a pretty steep line. So
So the thing we found is the derivative, right?
yes.
And the derivative.
So the
tells us
derivative,
The slope.
yes, and you can find the slope at different tangent lines on your curve.
Tells us the slope of the tangent line.
Yeah, because if you even put in like a -1, okay, so that would be 5 right here. But if you go to -1 and kind of, well, that line's not as steep right there. So, but at 2, you know, because with your disco, You know, that goes on forever. So it looks kind of vertical-ish. You know, it's not really. Okay. Good times, right? Welcome to calculus.
I want to cry.
Last seemed kind of easy.
This, trust me, once you get, it's not going to be bad. Okay, so let's go to,
The example.
and all I'm going to do is find the derivative. The rest of the stuff about, because it's finding the slope at those points. That's all it's doing, because you'd have a different slope at different points because it's a curve. But we're not going to worry about that right now. Okay, so we're going to do the derivative of that one.
Okay.
Oops. Okay, so what do I plug in?
Plug in the x plus delta x for the square root.
Okay. And then I'm just going to subtract out the function, right? Okay. Gee, this one doesn't look as complicated. Okay, so, hey, see, you're so mathy like me. Just do the flippy thing here. Okay, so if I do, okay, so we're gonna do the flippy thing. Tell me what I get up top when you,
X plus the square root of x.
you're gonna get, you're gonna get that, correct?
Yeah.
Yeah.
Just on top, right?
Yeah. Oh yeah, no, I have, at the bottom I'm not gonna do anything with here. I'm just gonna kind of leave it.
Oh, that'll be 1 over that, and then you just do that on the bottom again. I think it's-
Kind of. Okay, so up top, what's gonna happen? X minus X is gonna go away, right? Okay, this will simplify with this, right? That'll cross that out. So you're just left with 1. Okay, now. As delta X goes to 0, what happens down here?
So then it's x, the square root of x plus the square root of x is x.
Square root of X plus the square root of X.
It's just x. Oh my goodness.
No.
That, oh, 2x. Sorry.
Were you confused on that? Sam was like, I don't think you did.
No, I was thinking about
Okay, so this one, we start off with a hard one. Okay, so with this one, because the last time you did the flip sign, the conjugate things, do that, kind of leave that alone. When that canceled out, that went, and then, yeah, you have that right there. But it's as it goes to 0, what's happening here, okay? So,
You did the other flippy
That's our
thing,
slope.
the square root on top though.
Yeah, you can't leave the square root of anything.
That's breaking math.
well, for this, I left it, but
Are you breaking the rules of math right now?
no, it would just have a negative exponent on it. If I'm just doing slope stuff and I'm just gonna plug numbers in for X, I'm gonna leave it right here. But if you took it out of this, it's like you'd be taking it out of it would be this, and then all that does is tell you it's a negative. But I don't need you to do all of this. This is where I want you to be on this one. Because all you're gonna do with this one is plug in certain points of x to find the slope. And that's what kind of the rest of that problem is blah, 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 blah. At the points 1, 1 and 4, 2, what's the slope? Well, if you plug 1 in there, you get 1/2. So the slope at that point is 1/2. If you plug 4 in there, you get 1/4. So at that point, that is your slope.
So you don't really need one for when we plug that in.
Mm-mm. That's kind of the location of said point. But if you plug in that, that'll tell you what the slope is right at that point. And we'll get to the point where we do the derivative stuff and then you write an equation of a line. Not today. I'm not ready for Adam to completely melt down. Okay, next one.
How upset you would have been if you wasn't here the day you're teaching it.
Or at least you wouldn't have recorded it and sort of explain this all to me. I'd be like, I understand it a whole lot more. There's a lot of things.
They switched that over to T. If you'd rather put that as an X,
I am an X kind of guy.
do you want to do X?
Why is it same as F?
Yeah. So if you want to change that to an X, I know later on when you get into application of derivative stuff, a lot of time, since you're talking about like a change over time, you're talking about time. So yes, they will throw in T.
And I will gladly change to next.
Okay, so, and we said that. Okay, so this is using kind of your limit stuff because you're plugging in your 0. All right, so what do?
You got a 2 over x plus the delta x, and then you got the you do the minus
Did I do that right?
minus 2 over that. There you go. Yeah.
God, this makes me nervous. Okay.
Same.
I don't know how long I did this. Okay. Up top, what would your common denominator be? It'd be both things. So kind of take 2 times x oh wait. So I did 2 times this, and then I did negative 2 times that.
Wait, wouldn't
Can you back up? I know we've done this, but
Okay,
so
x plus delta x is my common denominator. So I took this side basically times top and bottom times x, and this side over here times x plus delta. Here, I can kind of write that.
I feel bad because I remember doing this in 8th grade. That it's still just
What common denominator?
Yeah.
Well, common denominator, you're used to 5 and 7. You know, in 8th grade, you're not worried about the rest of it. Okay.
go back, tell you yourself that burgers really is okay.
Okay, what happens here?
You can subtract the 2x minus the other 2x.
Okay, how do you divide fractions?
You don't.
Copy dot flip, right? Okay. Oh, I gotta go onto this page. Okay, so copy. Dot And when I flip this over, it becomes what?
1 over.
Interesting. Delta X.
Ah,
If you multiply by the reciprocal, you know, just kind of slap a 1 underneath there so you know it's flipped. Now what happens?
So the delta X just cancel out.
That will cancel out right there.
was -2.
And then remember, so what am I going to have here?
So then it would be x times x is x squared. We're mathing, guys.
Okay. Oh, when I boxed, I'm done. Okay, so the copy dot flip, that got rid, okay, stop. All she's gonna see in this whole video is me poking my head around the corner here.
Wait, why is it just X3?
Because as this goes to 0, that'll take that away, so you're left with x times x, and you had a -2 up top. Okay, that's kind of it for the first section. Go back to example 1. See if you can do that one. Just find the derivative of that.
2x times 3.
Yep.
Okay.
What was it? 2x minus 3. Okay. See what you maybe come up with trying to do the long way. So, Victoria, we went back to example 1. Do you want me to freeze this, do it, and then put my answer up there?
I need a calculator. I wish my class was this small.
No such luck. Okay.
It's okay, I get 2 class projects done in a row. Or at the end of it. That whole group of paper.
Nice.
Wait, c equals 2.
Don't worry about the c equals 2.
Okay. Is that how that works?
Never mind.
It's something called a long way. This is right. I don't know how this is right or how this works, but like. Okay. Oh.
Okay, now what you have to understand, you guys weren't really paying attention to what I asked you to do. I asked you to find the slope of a line.
Find the slope of the. Oh my god.
Your original equation was a line. That's y equals mx plus b.
So the slope is consistent.
Your slope would be 2.
Oh my.
Now, since it's linear, it's always gonna be 2 on that line. I purposely kind of threw this one in last just to practice this process. Now,
Well, we also did it.
We
but
were
you
tricked.
also did it. But I think you looked at it like, how did I just end up with a number and not some x? Because everything you had an x with it.
No, I messed it up because I didn't do the -3.
Oh, did you forget to? Oh, right here.
No, minus 2x.
Oh, and then change that. Yeah. Now, this is a line. Its slope should be 2. When you went through all that math, you came out with 2. But you know, looking at the equation now as a line, not just Oz asked me to do this. 2 is your answer, but it's a line. So every point on that line has a slope of 2. But now when you get into that curve stuff, obviously it's not gonna have the same slope at each tangent line, so, yeah, if you end up with this, well, then it was just a linear thing, but you did your math right. It's a lot of work to just say what you already knew, but
We should go back to like 7th and 8th grade, teach all the kids how to find the slope by using this.
and then show them a shortcut.
Yeah.
And say, oh, okay, well, here's.
Well,
Well, you could also just do-
Or you can do this.
Okay, but that's why I kind of did that. Okay, done. Stop recording. That's